Today's topic is Coulomb's law. The scientist Coulomb in 1785 has discovered a law of force between charged particles, and this is the Coulomb's law. So, it is said in the law that the force of interaction between two stationary points means point charges, this is proportional to the product of the charges and also inversely proportional to the square of the distance between them, and it acts along the line joining the charges. Now the force F is equal to, or F is proportional to Q1 Q2. Q1 is the charge of the first particle, Q2 is the charge of the second particle, and we are taking the product of it, that is Q1 Q2, and the distance between them is R. So F will be proportional to Q1 Q2 and inversely proportional to R square. And when you remove the proportional sign, there will be equal sign, and to put equal sign we need to put a constant which is whose value is in SI unit, that will be 1 by 4 pi epsilon naught. So here 4 pi epsilon here epsilon naught is the permittivity free space, and its value is 8.85 into 10 to the power minus 12 c square Newton inverse meter to the power minus 2. So the formula will be F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. If we put vector sign in the left side, that is F vector, so there will be R cap vector in the right side. So along the direction of the vector, depending on the direction, there will be the vector sign, and the Coulomb force is consistent with Newton's third law of motion. You need to remember few important points. Number 1, Coulomb's law is strictly applicable to the point charges. In experimentally, the separation between the charges should be large enough compared with the spatial dimension. Coulomb's law is found to be valid for any arbitrary large distance between the charges. There is no experimental evidence or any theoretical reasoning to expect a breakdown of this law at large distance. However, the domain of very small distance, there is experimental evidence to believe that the law breaks down for the distance of order of nuclear diameter, that is 10 to the power minus 15 meter. The law gives the correct total force only when the charges are at rest, that is, for moving charges it is not applicable. In case of moving charges, the question of magnetic forces arises. Number 3, the force of interaction between two charges is not changed by the presence of other charges, they will add up. Number 4, Coulomb's law resembles Newton's law of gravitation, that you all know. In gravitation, the forces are always attractive, but the Coulomb's force may be both attractive and repulsive. So this is the difference. Gravitational force is independent of the nature of the medium between the particles, but Coulomb's force is depending on the surrounding medium. The medium term is in the epsilon. If it is vacuum or air, it will be epsilon naught for air or vacuum, or for other medium that will be epsilon, which has some dielectric constant, or you can call it epsilon is equals to k into epsilon naught, where k is the dielectric constant. And obviously gravitational force is weaker, very weaker than Coulomb's force. Number 5, the law can be used to define a unit of charge, that is uh, the Coulomb in SI. So, like if we take Q1 is equals to 1 Coulomb, Q2 is equals to 1 Coulomb, and the distance between them, that is R, is 1 meter, then the force will be 1 by 4 pi epsilon naught into 1, that is 9 into 10 to the power 9 Newton. That is 1 Coulomb is the charge which that is placed at a distance of 1 meter from another similar charge in the vacuum. It experiences an electrostatic force of 9 into 10 to the power 9 Newton. So we are just putting the values at unit values and we are getting the force at 9 into 10 to the power 9 Newton. Next topic is the principle of superposition. Principle of superposition is a very known and it is applicable to many fields. So for electrostatics, it will be like that. The total force on a charge due to a number of other charges is given by the vector sum of the Coulomb forces exerted on the charge due to each of the other charges acting separately. Means if there are two charges, how they are acting on each other, that will not change with if there are more charges are present, which I have already told in one of the important points also. So this is the superposition principle. Means if the charges were individually present, whichever be the force between them, the two charges, every two charges, and not every two charges, like one is a test charge and we are calculating the force on that charge due to all other charges. So it will be just the sum of the other charge and the testing charge, sum of the forces applied on the testing charge. So if we have like n points charges like q1, q2, q3 up to qn, then the total force acting on the charge, if I take it as q0, then it will be like f1, f2, f3 and up to fn, and the total force will be F is equals addition of all the forces. So today's lecture is up to that. Next lecture we will learn about the electric field. The force is F and the electric field will be E, which will be F is equals to Q into E. That is for